Welcome back, students. Our next topic is air expands on heating. Air expands on heating. That is page number 83. Page number 83 in your textbook. Activity 8.5. Take a boiling tube, means normal test tube. Stretch a balloon tightly over the neck of the tube. You can use a paper tape to make it tight. Pour some hot water in a beaker. Insert the boiling tube with the balloon in the hot water. Observe for 2 to 3 minutes for any change in the shape of the balloon. Take the tube out. Let it cool down to the room temperature. Take some ice cold water in another beaker and place the tube with the balloon in cold water for 3 to 2 minutes. Observe the change in the shape of the balloon. So, what do you have to do? You have to take a test tube, cover it with a balloon. You can make it tight with the help of a tape. Now, you have to take hot water in the beaker, insert that test tube along with the balloon. So, what will happen is that hot water, the air inside the glass will expand. The air inside the glass tube or the test tube will expand, and the balloon will get inflated. Okay, the balloon will get inflated like this. This one is a balloon that is filled with it's a bottle. Instead of taking a test tube, here it's with test tube. This one with test tube. Here it is with a bottle. So, first you have covered this bottle with a balloon. Now, here we are applying heat so that the water in the beaker will be hot and the air will expand. The air will expand. Now, you can see the change in the shape of the balloon. So, from this experiment you will understand that air expands on heating. Air expands on heating. Okay, air expands on heating. Now, that means hot air molecules will take more space than cold air molecules. Hot air molecules will take more space than cold air molecules. So, when you heat the water in this beaker and a glass bottle is immersed inserted in this hot water, the air inside the glass bottle will expand, means it requires more space than cold water. So, you can see a change in the shape of the balloon. You can see the shape is increased. Okay. That means that air expands on heating. Now, you need to keep this bottle for some time so that the temperature of the bottle will be equal to the room temperature. Okay. Take out the bottle, cool it for some time to the room temperature. Now, what is next is that next you have to keep the same bottle in ice filled beaker. You have to keep the same bottle in ice filled beaker. Okay. So, what will happen is that this balloon will go into the glass bottle. That bulged portion will go into the glass bottle. Okay. This one you can see. When it is immersed, when the test tube is immersed in hot water, the balloon gets slightly bulged. Now, when it is immersed in cold water, what will happen? That balloon will get sucked into inside. That balloon will get sucked inside. Means air contracts on cooling. Air contracts on cooling. So, take a glass bottle with a narrow neck, stretch a balloon tightly over its mouth, keep the bottle in a water basin containing hot water. What happens to the balloon? Next, keep the balloon in water basin filled with ice cubes. You can see that in the first case, the balloon will increase, the size of the balloon will increase. That is, air in the bottle expands on heating and fills the balloon. Air in the bottle expands on heating and fills the balloon. That is, hot air molecules need more space than cold air molecules. The greater the heating, the greater will be the expansion. The greater the heating, the greater will be the expansion. Similarly, what will happen when it is placed in ice cube wash basin or in a beaker? It is filled with ice cube and you have to keep this bottle in the beaker. So, what will happen is that air will contract. Air will contract on cooling. Okay. So, now one more activity is here, that is this one. Activity 8.6. Take two paper bags or empty paper cups of same size. Hang the two bags in an inverted position on the two ends of the metal or wooden stick. Tie a piece of thread in the middle of the stick. Hold the stick by the thread as in a balance. Put a burning candle below one of the bags as shown in the figure. Observe what happens. Okay. So, first thing, you need to take two paper cup and using a thread, hold it in the inverted position. Hold it in the inverted position. So, take two paper cups which is in the inverted position with the help of a thread. Now, you tie that thread to a meter rod or a plastic or a rigid support. Just tie that two thread to a rigid support and a thread at the middle of that support, so that you can hold the whole thing with the help of that thread. Okay. That diagram is there in your textbook. Okay. Now, you have to place a candle under one paper cup. Now, you have to place a lighted candle under one paper cup. So, what you can see that the paper cup which is just above the lighted candle will move in the upward direction. The paper cup which is just above the lighted candle will move upward, and the balance will get disturbed. Okay. So, this activity suggests that as a warm air rises up, it pushes the bag above the candle. It pushes the bag above the candle, or we can say in another way, warm air is lighter and it rises up. warm air is lighter and it rises up. So, I told you in the class convection, warm air is lighter because it expands on heating. Air expands on heating, so the volume will increase but the mass is not changing. So, mass per volume is changing. Mass per volume decreases and it will become lighter and it is moving in the upward direction. So, hot air or warm air is lighter and it will move in the upward directions. That is why smoke always moves upward. Smoke always move in the upward direction because it is warm air. Warm air is lighter and it will move in the upward direction. Just underline that point. On heating, the air expands and occupies more space. When the same thing occupies more space, it becomes lighter. The warm air is therefore lighter than cold air. That is the reason that smoke goes up. In nature, there are several situations where warm air rises at a place. The air pressure in that place is lowered. The cool air from the surrounding areas rushes in to fill its place. This setups convection in air. You studied about land breeze and sea breeze now, isn't it? During daytime, the land will become very hot. So, air above the land is hot air. It will move upwards and cool air from the sea will get into to fill its space, isn't it? So, warm air is lighter and it will move in the upward direction, creating a low pressure area. Creating a low pressure area. Okay, creating a low pressure area. So, the cold air which is heavier from the surrounding will rush into that place to fill that gap. So, that leads to the convection of current in air. Convection of current in air. Okay. So, we discussed about air exerts pressure, then increased wind speed is accompanied by reduced air pressure. That is actually done by a mathematician, Daniel Bernoulli, that is known as Bernoulli's theorem. Then air expands on heating. Air expands on heating. So, when air expands on heating, it will be lighter and it will move in the upward direction and creates a low pressure region. That cold air from the surrounding will get into that place and that leads to the convection of current in air. Okay, thank you.